हरिः कर्ता।
Now let's try to demonstrate how scatter plots can be used to visualize the relationship between two continuous variables with respect to our data set that we were doing so far. So let's get me into Jupyter Notebook, and this is step 3, which is step 3. I'll write it as scatter plots. Okay, so I have my data set. So let me call this data set. Yeah, this is my data set. Let me keep this. So let me call up data dot columns. Yeah, let it be. So now let's begin. Suppose we have two variables, x representing the number of here let's take it as x as fixed acidity, y as volatile acidity, and let's try to explore the relationship between these two. Let's do that. So obviously to do that we need to import matplotlib lib.pyplot as plt. So let's create scatter plot. Let's create a scatter plot. So plt dot scatter. So now I have to provide x and y. So let me give data, and that's a fixed dot acidity. That's what my x, and let me give y. Y is volatile. Okay, let me directly copy from here. Volatile acidity. I just want to find out the relation, how it behaves, and what kind of pattern uh, of what kind of pattern it will expose the relation between the fixed acidity and volatile acidity. I just want to see the relation between them, nothing else. Okay, so I have to label also. So let me label this plt dot x label. So x label is fixed acidity. Let me put it in the same way. And similarly, let me go for the y label, t dot y label. And let me put it in same. Let me copy this volatile acidity and paste it here. And finally, let me put it the title plt dot title is a fixed acidity versus, let me say this way, volatile acidity, both. And finally let's show it, plt dot show. And okay, this is what the relation that we found. Obviously we cannot make out. It looks like a cluster. That's it. It seems like a cluster. So some extent we can see there is a positive movement, not completely, but at least if you see the, between volatile acidity and fixed acidity, if you see between them, fixed acidity and volatile acidity, so that's 0.22. Obviously this is positive, it's positive. So it's a positive, and that you can see here. It's a positive. I can clearly see the positive correlation, but how strong it is, it's not that strong. It's very, the strength is very low. It's 0.2. Okay, the strength is very low. So similarly, let's do it for others between these two. Let me try to find out. Let me do this. Okay, we got the minus 0.69, correct? Between alcohol and density. Let me do that. Alcohol and density. Let me exactly copy this. And here I'm gonna say alcohol. Here I'm gonna say density, alcohol, and alcohol. Density and density. And execute it. And here it is. You see that the pattern? It's a negative. There is a clear cut. There is obviously the, as the points are very close. Of course, this is huge data. It's 64,000 data points, and however the data points are pretty close. So as they are pretty close, and you can say that these are outliers, one or two, three, four, these are outliers, but this is pretty straightforward. And here you can see it's a linear equation. It seems like a linear equation, and it's a negative. It's clearly you can make out it's negative as it is going, as alcohol is increasing. As the alcohol is increasing, the density is reducing. Okay, as initially it's 9 and alcohol density is 1.001, then as it came to 14, the density has came down to 0.99. This is very clear. There is a clear cut a negative correlation here. And let's go for other correlations. Let me check up here. Point, we got the 0.44. That's between alcohol and quality. Let me do that. Alcohol and quality. Okay, let me copy this one. It would be much easier to handle. Alcohol and quality. Quality and execute it. Oh, okay. What kind of a correlation it is? Okay, so alcohol is increasing, the quality is, it has a pattern. That's it. When, okay, this is one pattern, this is another pattern, this is another pattern. So obviously at different level of quality. Okay, you have different level of alcohols with different level of qualities. Okay, you have a alcohol percentages from here to here with this quality. Okay, now let's take up another data. Okay, let's take the other ones. Let's take up this. So sulfur dioxide with the quality. Sulfur dioxide with the quality. Similarly, see here itself randomly we have done correlation. Randomly we have plotted the scatter plots, and we have found that positive correlation, negative correlation, a kind of pattern. And let's see what we are going to get it here. Sulfur. Okay, let's go for the sulfates and let's see. Sulfates and quality. Oh, similar one by and large. So let's go for the other one. Sulfur dioxide. Sulfur. Directly check up the uh, it's free dot sulfur dex, no, total dot sulfur. So let me take up this one. It's total, it's total dot sulfur dot dioxide, and let's see what relation we're gonna get here. And here it is, sulfates. Let me change it and execute it. Okay, by and large we got the same relation. So let me look for one more. Data dot columns. So color, chlorides, total sulfate. Okay, residual sugar. Let me take, go for residual sugar. And okay, we'll do one thing. Let's take the sulfates. We'll take the chlorides and pH. Let's see what relation we'll get it here. And pH. pH. Chlorides and pH. Let's see what relation we're gonna get it here. And pH. pH. Execute. Okay. Okay. We got, we cannot say there is a proper correlation, but you can say that to an extent, as the chlorides increasing the concentration, the pH value is also increasing, but not that level. So obviously it would be the value would be lesser, so we cannot say any proper, we cannot give any proper correlation, and it cannot be a linear equation also. It could be some other non-linear equation, the non-linear relation also possibility. So if you keep on exploring the relation between any two variables, you can find out, you may find some magnificent and mesmerizing relations too. Okay, I would request you to explore the relationship between other variables too. We have done it for 5 to 6 variables. I would request you to explore for other variables.